Okay, so today we're talking about zero and negative exponents. Zero as an exponent. Let's say we have 5 to the 0 power. That would equal 1. Let's say we have 2 to the 0 power. That would equal 1. If we have a to the 0 power, it equals 1. If we have 1/3 to the 0 power, it equals 1. So regardless of what the number or variable is, if it's raised to the 0 power, it equals 1. Now why is this true? What's 2 to the 3rd power? So I heard somebody say 8. What about 2 squared? 4. What about 2 to the 1st power? Do you see a pattern forming between 8, 4, and 2 right here on the product? What's happening? It's being divided by 2 each time, right? So if we follow that pattern, 2 to the 0 power would be 2. Would it be 2 or would it be anything? It would just, it equals 1. It would be 2 divided by 2, which equals 1. Now, because of this pattern, we know that anytime 0 is the exponent, the answer is 1, regardless of what the number is. So let's say we have 2468 to the 0 power. What would that equal? 1. What would c to the 0 power equal? 1. Regardless, excuse me, any number or variable raised to the 0 power equals 1. So let's try this again. Let's say we have 346 to the 0 power. What does that equal? What is x to the 0 power? 1. What is 248 to the 0 power? 1. What is 1243 to the 0 power? 1. What is z to the 0 power? 1. Bless you. Excuse me. So let's say we have a negative exponent. So if we have a negative exponent 6 to the negative 4th power, how do we make a negative exponent positive? To make a negative exponent positive, we have to put it in the denominator. To make a negative exponent positive, we send to the denominator. Okay, so the question about the calculator right now. How do you make a negative exponent positive? Well, if you input it into your calculator and you input 6 to the negative fourth power, enter, it probably gives you a decimal, right? Okay, if you change that decimal into a fraction, so math fraction, I'm sorry, can I borrow it? So let's say we have negative 8 to the negative 1 power. So how would I simplify this? How do, how do I write this using positive exponents? Now when the exponent is 1, do we really need the exponent? Yes, you can, but it won't be, like it will not be something you see, because you can always imply that the exponent is 1. So let's say we have 3 to the negative 4th power. What would this equal? To the 4th power. Now can we actually multiply 3 to the 4th power? What would that equal? 1 over 81. So does it necessarily mean that this answer is incorrect? Or this one? No, they're both correct answers, right? So you were asking me earlier. So unless unless the number, like in this case, 1 over negative 8, this would be a negative answer. But the exponent in a simplified would not be negative. Okay, let's try it again. Let's say we have negative 4 to the negative 3 power. First of all, we need to make this into positive exponents. What would be the positive exponent? So negative 4, the positive exponent would be 3. Yes or no? Now if I multiply this out, what am I multiplying out? Negative 4 times negative 4 times negative 4. This means what? Negative 64. Why is my answer negative in this case? Because I'm multiplying 3, I'm sorry? Because of Dorito, okay, I'm multiplying 3 negative numbers, right? Yes. Because to make a negative exponent positive, you put it in the denominator. So this is the process of simplifying a negative exponent. Let's try this again. Let's say we have 7 to the negative 1 power. What would that equal? 1 over 7. What if we have negative 3 to the negative 2 power? 1 over, okay, so these were two rules, right? Okay, negative 4 to the negative 3 power ended up negative because look at this. We're multiplying negative times a negative becomes a what? Positive, right? And that positive number times negative 4 equals a negative. Does that make sense? And right here we're multiplying negative 3 times negative 3, and that's why this is positive. Yes? So just going over those two rules. What were the two rules? To make a negative Can you repeat that again? Okay. So let's try this again. Let's say you have to simplify. So simplify is your instruction, and this is the problem. 4x y to the negative third power. How would you simplify this? So let's take a close look at it. First of all, where's our negative exponent? So what variable does the negative exponent belong to? Y. So if it belongs to y, how do we make that negative exponent positive? Okay, how do we make the y exponent positive? Okay, so that's what I'm going to do. Y cubed. So what's left that does not have a negative exponent? 4 and do we have all positive exponents now? Yes, Tim. Okay. So why does the y exponent turn to a positive? Let me go back. Remember right here, if we have 2 to the negative 1 power, what would be the pattern to follow? This number, right? The product of the previous one divided by 2, so that equals 1/2. See how this, to make this negative exponent positive, it went to the denominator? Now I could continue this pattern, and I'll have a lot of space here, but if I write it on this side, and I say 2 to the negative 2 power, that equals this, right? 1/2 divided by 2. What is 1/2 divided by 2 equal to? 1/4, right? So from this, we can conclude that to make a negative exponent positive, you put it in the denominator. Like that would be the shortcut to it. Does that kind of help? Let's try it again. If you have negative 1.23 to the 0 power, what does that equal? 1. Now let's say you get something like this, 1 over w to the negative 4th power. If to make a negative exponent positive when it wasn't in the denominator, we had to put it in the denominator, what do you think we have to do this time? How do we get this negative exponent to be a positive exponent? Put it in the numerator. Actually going backwards. Yes. So let's say we have, yes. So your question is if we had 2 over w to the negative 4th power. Now the 2 is already a positive exponent, right? So we would leave it in the numerator, and to make the negative exponent positive, we do the opposite to the numerator. So let's say we have 3ab to the negative 2 power. What would that equal?